Okay, today we're still going to be talking about solving rational equations. Just kind of a little refresher, I wanted to make this video in case anybody was absent on Monday, or if anyone's still not super comfortable with doing this, if they still need help. So here's what we'll do. If you feel great about solving rational equations and you think you've got it, go ahead and do the 3 problems on the notes, and then you can give it to the sub. She's going to check your answers, and if you have them right, then you can go ahead and work on the worksheet and not even worry about the videos. Okay. So if you need help, this is for you. If not, go ahead and do those 3 problems, get them checked, and you're free to work. Okay. So let's do the first problem. The first thing you want to do is break down all your denominators. Make sure you simplify them. So this first fraction, you can take an x out of both terms, right? So if I take an x out of both, I'm left with x minus 1. Okay? That second number, anytime you have a whole number, it's like saying it's over 1. Okay? So all my fractions, all the denominators are simplified, right? Now we're going to find a least common denominator. This is going to be something that all 3 go into. So we're going to need an x. We're going to need an x minus 1, right? And 1 goes into that because 1 goes into anything, and x minus 1 goes into that also. Okay, so you need to make sure all 3 denominators, or all the denominators, go into that least common denominator. Okay, next thing we're going to do is get all of our fractions to have this denominator. The first one already has it, so you don't have to mess with it at all. The second one, we have 1 over 1. Okay, so we need an x minus 1 in the denominator. So we're going to multiply by x minus 1, because we don't have any of those parts in here. Okay, what you do to the bottom, you have to do to the top. Okay, so if we multiply this times 1, 1's not going to change anything, right? You'll still get the same x minus 1. So let's go ahead and distribute that x. So x times x is x squared. X times negative 1 is negative x. All right. So the last fraction, we have an x minus 1, but we're missing an x. Okay, so we're going to multiply an x to the top and the bottom. So that gives us 2x over x minus 1. All right, now that you have all of your fractions the same, we're going to look at the numerators. You don't have to worry about the denominators anymore because, like I said, they're all the same. So let's look at our numerators. What I do is look at my original problem. Okay, I'm going to start out with 2. That fraction didn't change at all. Minus my second one. My second one changed to x squared minus x. And remember, when you're subtracting, you want to put that in parentheses because you're going to have to distribute that minus sign. Okay, and equals, I'm just going across my original problem. That last fraction changed to 2x. Okay, so let's go ahead and distribute that minus sign. So we have 2 minus x squared. And if we distribute it to that x, a negative times a negative gives you a positive x. Okay. We talked about on Monday, anytime you have an x squared, you need to get it to equal 0. So we need one side to equal 0. Now I like my x squared to be positive. For me, it makes it so much easier. So I would move everything to the right. That way my x squared is positive. Okay, so I'm going to add the x squared. I'm going to subtract the 2. I'm just going to do it in one step here. And I'm going to subtract the x. That way, I have a 0 on this side. Okay. So 0 equals, I'm going to have an x squared. That didn't combine with anything. My x's will combine. So 2x minus x is a positive x minus 2. Okay. And now we're going to factor it. So first times the last, that gives me 2. The factors of 2 would be 1 times 2. The only way we can get a positive 1 in the middle is to do 2 minus 1. Okay, so I'm going to have an x minus 1 and an x plus 2. All right, and that's just factoring. The next part, we're going to set each factor equal to 0. So we're going to set x minus 1 equal to 0 and x plus 2 equal to 0. I'm running out of room here. I'll do it up here. X minus 1 equals 0. Okay, so I'm going to add 1 to both sides, and x equals 1. Okay. And any time you have just an x here, what happens is it's just the opposite. Okay, if you want to do the shortcut. But whenever you get a number in front of the x, it makes it a little more complicated. So I would actually go ahead and solve for x like we're doing right now, especially if you have a number in front of x. So you would subtract 2, so x equals negative 2. All right, so I got 2 answers on this one. I need to make sure both of them will work in my problem. Okay, so let's go back to that least common denominator. The reason we check this least common denominator is because you cannot divide by 0. Okay, so if I plug these in and either one of them gives me a 0 in my denominator, that's not an answer. Okay, you can't do that. So let's check the 1. If I plug in a 1 into any part of this least common denominator, will I get a 0? And the answer is yes. If I plug in 1, 1 minus 1 is 0, okay, that answer won't work. Okay, let's try the negative 2. If I plug in a negative 2, will I get 0? Okay, and you don't. So the only answer you have for this problem is negative 2. The 1 won't work. All right, and there is a lot of work on these problems. It's not necessarily hard. You've done all of this stuff before in separate parts. We've just never done it all in one problem. Okay, so it does take a lot of time. That's why I'm giving you 2 days to do about 10 more problems. Okay, and then Friday I'll be there to answer any questions you have over this stuff. All right, number 2. We need to make sure all of our denominators are simplified. So let's look at that last one. We can break that down. This is a difference of 2 perfect squares. So it would be x plus 4 and x minus 4. Okay, they're different signs because we need them to cancel out in the middle there. All right, so our least common denominator. We need to have an x minus 4. And we need an x plus 4. That way all 3 fractions, all 3 denominators will go into this. All right, so next step is to get all of our denominators the same. So we need all of them to have this common denominator here. So let's take that first fraction. We have x minus 4 in the bottom. So to get this common denominator, we're going to have to multiply by x plus 4. And what you do to the bottom, you have to do to the top. Okay, so we're going to multiply top and bottom by x plus 4. Okay, if you distribute the 1 times anything is just itself. 1 times x is still x. 1 times 4 is still 4. Okay, so that's our first fraction. Second fraction, we have an x plus 4 in the denominator. So if we want to get that common denominator, we're going to have to multiply by x minus 4. That way we have both of those parts there. Okay, what you do to the bottom, you have to do to the top. All right, same as the last fraction. 1 times anything is just itself. So that's going to give me x minus 4 here. All right, so all of our fractions have x plus 4, x minus 4 in the denominator. So I don't have to worry about the denominator anymore. Now I'm worried about my numerator. So let's go back to our original problem, and we're going to go through and rewrite this. My first fraction changed to x plus 4. And then plus, I'm looking at my original problem when I'm doing this. So plus, my second fraction changed to x minus 4. And then equals, and my last fraction didn't change, that's going to stay 8. Okay, and now I can solve. Okay, combine like terms, so x plus x is 2x, 4 minus 4, those will cancel. So 2x equals 8. Okay, solve for x, so divide by 2, and x equals 4. Okay. Before you make that your final answer, go back to your least common denominator and see if you plug this in, will you get a 0? Because you cannot divide by 0. Okay, it won't work. So if I plug in a 4, will I get a 0 in any one of those parts? And you do. 4 minus 4 is 0. So that answer won't work. And we don't have any other answer, so our final solution would be no solution at all. That would be your answer.